Welcome back, students. This is EduTube, and you're watching our series dedicated to helping Virtual University Pakistan students ace their math exams. If you're feeling overwhelmed by your upcoming math exam and haven't studied much this semester, you're in the right place. We've got you covered. We've already covered lectures 17 through 19, and today we're diving into lecture 20, Operations on Matrices. This series is all about simplifying concepts and helping you prepare in the easiest, most effective way possible. So, let's get started. 1. What is the result of adding two matrices? A matrix B, a scalar C, a vector D, a matrix of the same size as the original matrices answer. D, a matrix of the same size as the original matrices explanation. When adding matrices, both matrices must have the same size. The result is a matrix with the same dimensions, where each element is the sum of corresponding elements in the two matrices. 2. What is required for matrix multiplication? A. The matrices must have the same dimensions. B. The number of columns in the first matrix must equal the number of rows in the second matrix. C. The matrices must be square. D. The matrices must have the same number of rows and columns. Answer. B. The number of columns in the first matrix must equal the number of rows in the second matrix. Explanation. Matrix multiplication is only possible when the number of columns in the first matrix is equal to the number of rows in the second matrix. The result will have the number of rows of the first matrix and the number of columns of the second matrix. 3. What is the identity matrix? A matrix with all elements equal to 1. B. A matrix with all diagonal elements equal to 1 and others equal to 0. C. A matrix with all elements equal to 0. D. A matrix with random elements. Answer. B. A matrix with all diagonal elements equal to 1 and others equal to 0. Explanation. The identity matrix is a square matrix where the diagonal elements are 1, and all other elements are 0. It is the equivalent of the number 1 in matrix multiplication, as any matrix multiplied by the identity matrix remains unchanged. 4. Which operation is not part of matrix operations? A. Matrix addition. B. Matrix subtraction. C. Matrix division. D. Matrix multiplication. Answer. C. Matrix division. Explanation. Division is not directly defined for matrices. Instead, multiplication by the inverse matrix is used to achieve division-like results. 5. What does it mean for two matrices to be equal? A. They have the same dimensions and the same corresponding elements. B. They have the same size. C. They have the same diagonal elements. D. They have the same number of rows. Answer. A. They have the same dimensions and the same corresponding elements. Explanation. Two matrices are equal if they have the same size and all corresponding elements are identical. 6. What is the transpose of matrix? A. The matrix multiplied by itself. B. A matrix where rows become columns and columns become rows. C. A matrix where all elements are negated. D. A matrix with all elements shifted by one position. Answer. B. A matrix where rows become columns and columns become rows. Explanation. The transpose of a matrix is formed by interchanging its rows and columns. For example, element I, J, in the original matrix becomes element J, I, in the transposed matrix. 7. Which of the following operations can be performed on matrices? A. Addition. B. Subtraction. C. Multiplication. D. All of the above. Answer. D. All of the above. Explanation. Matrices can undergo addition, subtraction, and multiplication. However, division is not a defined operation for matrices. 8. How do you multiply a matrix by a scalar? A. Multiply each element of the matrix by the scalar. B. Multiply only the diagonal elements by the scalar. C. Multiply the entire matrix by the scalar. D. Add the scalar to each element of the matrix. Answer. A. Multiply each element of the matrix by the scalar. Explanation. To multiply a matrix by a scalar, multiply each individual element of the matrix by the scalar. 9. What is the determinant of a matrix used for? A. To find the inverse of a matrix. B. To determine if a matrix is singular or invertible. C. To add matrices. D. To transpose a matrix. Answer. B. To determine if a matrix is singular or invertible. Explanation. The determinant is used to determine if a matrix is invertible. If the determinant is 0, the matrix is singular and does not have an inverse. 10. Which of the following is true for matrix multiplication? A. Matrix multiplication is commutative. B. Matrix multiplication is associative. C. Matrix multiplication is distributive. D. Both B and C are true. Answer. D. Both B and C are true. Explanation. Matrix multiplication is associative, i.e., AB, C equals A, B, C, and distributive, i.e., A, B plus C, equals AB plus AC. However, it is not commutative, meaning AB does not equal BA in most cases. 11. What is the inverse of a matrix? A matrix that, when multiplied by the original matrix, results in the identity matrix. B. A matrix with all elements negated. C. A matrix with rows and columns swapped. D. A matrix that cannot be multiplied by the original matrix. Answer. A A matrix that, when multiplied by the original matrix, results in the identity matrix explanation. The inverse of a matrix, when multiplied by the original matrix, gives the identity matrix. Not all matrices have an inverse. Only those with a non-zero determinant are invertible. 12. What is the dimension of a matrix? A. The number of rows and columns in the matrix. B. The sum of the rows and columns. C. The number of diagonal elements. D. The total number of elements in the matrix. Answer. A. The number of rows and columns in the matrix. Explanation. The dimension of a matrix is expressed as the number of rows and columns it has. For example, a matrix with 3 rows and 2 columns is a 3 by 2 matrix. 13. Which operation can be used to find the inverse of a matrix? A. Matrix subtraction. B. Matrix multiplication. C. Matrix transposition. D. Gaussian elimination. Answer. D. Gaussian elimination. Explanation. Gaussian elimination is a method used to find the inverse of a matrix, if it exists. It involves row operations to transform the matrix into its reduced row echelon form. 14. What is the scalar product of two matrices? A. The sum of all elements in both matrices. B. The multiplication of corresponding elements. C. The sum of the diagonal elements of both matrices. D. The result of matrix multiplication by a scalar. Answer. B. The multiplication of corresponding elements. Explanation. The scalar product, also known as the dot product, of two matrices involves multiplying corresponding elements of the matrices and summing the results. 15. If matrix A is 3 by 2 and matrix B is 2 by 4, what will be the dimension of their product, AB? A. 3 by 4. B. 2 by 2. C. 4 by 3. D. 5 by 5. Answer. A. 3 by 4. Explanation. When multiplying matrices, the number of rows in the first matrix, A, and the number of columns in the second matrix, B, determine the dimensions of the resulting matrix. In this case, the product will have 3 rows from matrix A and 4 columns from matrix B, resulting in a 3 by 4 matrix. 16. Which of the following operations is valid for two matrices of different sizes? A. Addition. B. Subtraction. C. Multiplication. D. All of the above. Answer. C. Multiplication. Explanation. Matrix multiplication can be performed when the number of columns in the first matrix is equal to the number of rows in the second matrix, regardless of their overall size. Addition and subtraction require matrices to be of the same size. 17. What is the result of multiplying a matrix by the scalar 0? A. A zero matrix. B. The original matrix. C. The identity matrix. D. A matrix with all elements as one. Answer. A. A zero matrix. Explanation. When any matrix is multiplied by the scalar 0, all elements of the matrix become 0, resulting in a zero matrix. 18. In which situation can a matrix have an inverse? A. If the matrix is a square matrix. B. If the determinant of the matrix is 0. C. If the matrix is not square. D. If the determinant of the matrix is non-zero. Answer. D. If the determinant of the matrix is non-zero. Explanation. A matrix has an inverse only if it is square, same number of rows and columns, and has a non-zero determinant. If the determinant is 0, the matrix is singular and does not have an inverse. 19. What operation does matrix transposition perform? A. It multiplies all elements by 1. B. It swaps rows and columns. C. It negates all elements. D. It inverts the matrix. Answer. B. It swaps rows and columns. Explanation. The transpose of a matrix involves swapping the rows and columns. For example, element I, J, in the original matrix becomes element J, I, in the transposed matrix. 20. What is the result of multiplying a matrix by its own inverse? A. The zero matrix. B. The identity matrix. C. The matrix itself. D. The original matrix minus its inverse. Answer. B. The identity matrix. Explanation. The product of a matrix and its inverse is the identity matrix, which acts as the 1 in matrix multiplication. 21. How do you perform matrix subtraction? A. Subtract each element of the second matrix from the first. B. Multiply each element of the first matrix by the scalar 1. C. Subtract the inverse of the second matrix from the first. D. Add the second matrix to the inverse of the first matrix. Answer. A. Subtract each element of the second matrix from the first. Explanation. To subtract matrices, subtract corresponding elements in the second matrix from those in the first matrix, provided both matrices have the same dimensions. 22. What is the rule for matrix multiplication? A. The number of rows in the first matrix must equal the number of rows in the second matrix. B. The number of columns in the first matrix must equal the number of rows in the second matrix. C. Both matrices must have the same dimensions. D. The matrices must be square. Answer. B. The number of columns in the first matrix must equal the number of rows in the second matrix. Explanation. Matrix multiplication is defined when the number of columns in the first matrix matches the number of rows in the second matrix. 23. What is the result of a matrix multiplied by the identity matrix? A matrix with all elements is 0. B, the original matrix itself. C, A matrix with all diagonal elements is 1. D, A matrix with all diagonal elements is 0. Answer B, the original matrix itself. Explanation: multiplying any matrix by the identity matrix results in the original matrix unchanged, similar to multiplying a number by 1. 24. What is the role of the determinant in matrix operations? A, it indicates if a matrix can be added or subtracted. B, it determines if a matrix is singular or invertible. C, it shows the size of a matrix. D, it represents the number of non-zero elements in a matrix. Answer B, it determines if a matrix is singular or invertible. Explanation: the determinant of a matrix helps determine whether the matrix is invertible. If the determinant is non-zero, the matrix is invertible. If the determinant is 0, the matrix is singular and cannot be inverted. 25. What does matrix multiplication satisfy in terms of properties? A, commutativity. B, associativity. C, distributivity. D, both B and C. Answer D, both B and C. Explanation: matrix multiplication is associative and distributive, meaning AB, C equals A, BC, and A, B plus C, equals AB plus AC. However, matrix multiplication is not commutative, so AB does not equal BA in general. 26. If matrix A is a 2 by 3 matrix, and matrix B is a 3 by 4 matrix, what is the dimension of the product AB? A, 2 by 4. B, 3 by 3. C, 2 by 3. D, 4 by 2. Answer A, 2 by 4. Explanation: the number of rows in the product matrix will be the number of rows in matrix A, 2, and the number of columns will be the number of columns in matrix B, 4. So, the resulting matrix will have dimensions 2 by 4. 27. Which matrix operation is used to find the adjoint of a matrix? A, transposition. B, determinant calculation. C, inversion. D, cofactor expansion. Answer D, cofactor expansion. Explanation: the adjoint of a matrix is found by taking the cofactors of each element, forming the cofactor matrix, and then transposing it. 28. Can two non-square matrices be multiplied together? A, yes, if their dimensions allow it. B, no, they must both be square. C, yes, as long as they have the same number of rows. D, no, multiplication is only possible with square matrices. Answer A, yes, if their dimensions allow it. Explanation: non-square matrices can be multiplied as long as the number of columns in the first matrix equals the number of rows in the second matrix. 29. What is the role of the trace of a matrix? A, is the sum of all elements in the matrix. B, is the sum of the diagonal elements of a square matrix. C, it represents the rank of the matrix. D, it is the inverse of the matrix. Answer B, it is the sum of the diagonal elements of a square matrix. Explanation: the trace of a matrix is the sum of the diagonal elements of a square matrix. It is only defined for square matrices. 30. Which operation is used to find the inverse of a matrix? A, Gaussian elimination. B, matrix multiplication. C, matrix addition. D, matrix subtraction. Answer A, Gaussian elimination. Explanation: the inverse of a matrix is typically found using Gaussian elimination, which involves applying Rao operations to transform the matrix into its inverse, if it exists. 31. Which matrix operation is used to scale a matrix by a constant value? A, addition. B, subtraction. C, multiplication by a scalar. D, transposition. Answer C, multiplication by a scalar. Explanation: to scale a matrix by a constant value, each element of the matrix is multiplied by that constant, also known as a scalar. 32. What type of matrix has only one row? A, column matrix. B, row matrix. C, square matrix. D, identity matrix. Answer B, row matrix. Explanation: a row matrix is a matrix that has only one row and multiple columns. It is also called a 1xn matrix. 33. What does the cofactor matrix help to calculate? A, determinant. B, inverse. C, transpose. D, identity matrix. Answer B, inverse. Explanation: the cofactor matrix is used to find the inverse of a matrix, especially in the case of calculating the adjoint of the matrix. 34. What happens if you multiply a matrix by a zero matrix? A, the result is the zero matrix. B, the result is the original matrix. C, the result is an identity matrix. D, the result is undefined. Answer A, the result is the zero matrix. Explanation: when a matrix is multiplied by a zero matrix, all elements of the resulting matrix become zero, resulting in a zero matrix. 35. What is the rule for adding matrices? A, the matrices must have the same number of rows. B, the matrices must have the same number of columns. C, both A and B are true. D, there are no specific rules for matrix addition. Answer C, both A and B are true. Explanation: matrix addition is possible only if both matrices have the same number of rows and columns, meaning they must have the same size. Let's quickly recap what we covered in Lecture 20, Operations on Matrices. We started by understanding matrix addition and subtraction, where we saw how to add or subtract matrices element by element, as long as they have the same dimensions. Then, we moved on to matrix multiplication. Remember, we can only multiply two matrices if the number of columns in the first matrix equals the number of rows in the second matrix. Matrix multiplication is done by multiplying each row of the first matrix by each column of the second matrix and summing up the results. We also explored scalar multiplication, where a matrix is multiplied by a single number, or scalar. This simply means multiplying each element of the matrix by that scalar. Finally, we touched on matrix transposition, where we swap the rows and columns of a matrix, and the concept of the inverse of a matrix, which is crucial for solving certain types of equations. These operations are fundamental in working with matrices, so make sure to practice them regularly to build your confidence. The more you work with matrices, the easier these operations will feel. That's all for today. I hope this video helped you understand the operations on matrices more clearly. Make sure to go through the previous lectures if you haven't already, and don't forget, the more you practice, the better you get. If you found this video helpful, make sure to hit that like button and subscribe to EduTube for more exam preparation content. We've got more lessons to cover, so stay tuned for upcoming videos on Lecture 21 and beyond. Keep practicing, stay confident, and I'll see you in the next video. Best of luck with your studies.